In this video, we're going to take a look at law of detachment and law of syllogism. So we're going to start first with the law of detachment. The law of detachment has a conditional statement, and then a fact saying that the conditional statement is true, and then a conclusion. So, for example, if it is Saturday, we'll use this example later too. If it is Saturday, then there is no school. Let's just say today is Saturday. So what do I know? There is no school today. Okay, so general principle, general idea, if-then statement. Then we have a specific example, something that happens. Today is an example of something that happens in the if-then statement. And then our conclusion, there is no school today. It's almost so easy that sometimes it actually gets a little bit confusing because you feel like there should be more to this. So let's look at some examples here. This is one straight off an old SOL. Okay. And I'll show you a really easy way to deal with this. So if a shape is a parallelogram, then the opposite angles are congruent. We know a rhombus, specific example, rhombus, is a parallelogram. So what then do we know? We'll take a look. We can actually just we've got parallelogram, parallelogram. So basically I want everything after that. We know that a rhombus has opposite angles that are congruent. And sure enough, we've got that right here at A. A rhombus has opposite angles that are congruent. So, let me show you another example. Okay, a gardener knows that if it rains, the garden will be watered. It's raining. What conclusion can he make? He can make the conclusion that the garden, will be watered. Okay, you see how this is working? If-then statement, we get the hypothesis, which is the first part of my statement, and then we write down the conclusion. So let's look at an example 2 here. Is this a good example of the law of detachment? So here's our given statement, here's our if-then statement. If you make a field goal in basketball, now if you're not really familiar with basketball, you're feeling like, well, maybe field goals with football. There is a field goal in football and also in basketball. Field goal in basketball just means that you get the ball through the hoop, it's a 2-point shot in basketball, so don't worry too much about that. So if you make a field goal in basketball, you score 2 points. We know Jenna scored 2 points, so you conclude Jenna made a field goal. Is that correct? Well, remember, we want to have the hypothesis. What is Jenna scores 2 points in basketball? That's the conclusion. Okay? That's not the hypothesis. It should say that Jenna scored a field goal, therefore she scored 2 points. This is not a good example of the law of detachment. The reason being, we need the hypothesis, not the conclusion for my specific example. Let's look at one more. Is this a good example of the law of detachment? A student gets an A on the final exam, then the student will pass the course. Joan gets an A on the geometry final exam. So look, A on the geometry exam, that's a specific example, a certain kind of exam. A on the exam, what do we know? Joan will pass the geometry course. Is that law of detachment? Yes, it is. All right, so that's the first one, law of detachment. It's pretty simple. Law of syllogism is just a little bit trickier. It's not much trickier, but a little bit trickier. So this one adds another layer. So P implies Q, Q implies R, then P implies R. It's a bit like, notice the matching statements, we can kind of chop them out and I'm left with P implies R. So let's again write out an example. Actually, let's just look at an example here. Okay, if a quadrilateral is a square, then it contains 4 right angles. So this would be my P statement implies Q. If a quadrilateral contains 4 right angles, so that's my Q, implies then it's a rectangle, P. Or I'm sorry, not P. Q implies R. Okay? So what I do with this, and now this is pretty simple. I know it's a lot of reading, but that's just kind of what the section is. What I'm going to do is I'm going to cross out the parts in common. So if it's a square, then it contains 4 right angles. If it contains 4 right angles, then it's a rectangle. So notice the 4 right angles, how that copies in both sections. I can actually kind of get rid of them, and my final answer turns out to, if a quadrilateral is a square, then it's a rectangle. So that's law of syllogism. You stack 2 statements, they have to have a connector, and this is what's really important. Notice this Q statement, it's at the end of one and it's at the beginning of another statement. It needs to be at the end of one, the one that's the same needs to be the end of one and the beginning of another. Let's take a look at another example. All right, so if the circus is in town, then the tents are at the fairground. If the tents are at the fairground, then Paul is working as a night watchman. Do I have sets in common? I do. I've got tents at the fairground, so I'm going to underline those. Actually, I can just cross them out. Those are going to go away. What am I left with? If the circus is in town, then Paul is working as a night watchman. And there you go. There's your final answer. Now let's look at 1 or 2 cases where this might be a little trickier. Let's look at this one. If you are studying geometry, then you're studying math. If you're studying parallel lines, then you're studying geometry. Now, this is the temptation. This is what some students do. They say, oh, I always cross out these 2, and then I'll see what I have left over. And their final answer is, if you're studying geometry, then you're studying geometry. Well, wait a second. That doesn't make any sense. Let's go back and take a look at this. Notice that studying math and studying parallel lines, that's not the same. What is the same? Studying geometry and studying geometry. So what's our final answer here? If you are studying parallel lines, then you are studying math. Okay? Notice how they switch the statements on us. They almost put them in reverse order. That's okay as long as what I'm crossing out is on the corners. Let's look at one last example. Is this an example of the law of syllogism? If it's Saturday, then there is no school. If it's summer, then there is no school. What 2 parts do I have in common? There's no school, there's no school. Okay? But notice they're both conclusions. They're both at the end of my statements. So this is not an example of the law of syllogism. Okay? This is not an example. Why? Well, because it would have to say if there is no school and then some other statement. You could say if there is no school, then I don't have to turn in homework or something like that. And so if it's Saturday, then I don't have to turn in homework. That would be an example. But notice here, both of these guys are in the conclusion. I need 1 in the hypothesis with the if statement, 1 in the conclusion. So that wraps up our lesson on law of detachment and law of syllogism.